The job of load balancing is to evenly distribute load from incoming network traffic across a group of backend resources or servers. Azure Load Balancer is fully managed service and provides high availability for your application. In this video, we will be covering what is Azure Load Balancer, traffic distribution with Azure Load Balancer, selecting a load balancer solution, configuring a public load balancer, and creating a load balancer. In the end, we will also share details about our free Azure Solution Architect Masterclass, which will not only help you understand basics, but it will also give you an idea of the learning path to follow. It would be helpful, especially when you're preparing for Azure Solution Architect certification, which requires you to clear 2 exams. That are Microsoft Azure Architect Technologies AZ-303 and Microsoft Azure Architect Design, that's AZ-304. For the certification exam, you should have an understanding of Azure Load Balancer. Welcome to another episode of Azure video series from K21Academy, where we take you from complete beginner, covering configuring infrastructure, authentication and securing data solution for the cloud and Azure storage, to all the way identity and security, business continuity strategy, deployment, migration, integration, and infrastructure strategy, including how to prepare for the AZ-303 and 304 certification exam. We have taken a clip from one of our certification training program on Microsoft Azure Architect Technologies, that's AZ-303, and in this clip, our instructor will talk about Azure Load Balancer. So, this is a clip taken from a module on implementing load balancing and network security. Now let's hear from an expert trainer on the same.
Implement load balancer. So with Azure Load Balancer, you can spread user requests across multiple virtual machines or other services. The way you can scale the app to larger sizes than a single virtual machine can support. And you ensures that all the users get the service even when the virtual machine fails. So we're going to use something called Health Probes to make sure that the backend servers are up and running. If something is not working, we're not going to send the request to them. So that's how the load balancer works. To start with, Azure Load Balancer is a service you can use to distribute traffic across multiple virtual machines. So load balancers use a hash-based distribution algorithm. By default, a 5-tuple hash is used to map traffic to available servers. The hash is made up of 5 elements. First is source IP, which is the IP of the requesting client, source port, the port of the requesting client, destination IP, the destination IP of the request, destination port, which is the destination port of the request. Finally, the protocol type, whether it's a TCP or a UDP. So this is so the picture shows how it is how the traffic is load balanced between the backend VMs here. So it goes with the 5-tuple hash, and the 5 elements are source IP, source port, destination IP, destination port, and protocol. So it supports both inbound and outbound scenarios and provides a low latency, high throughput, and scales up to millions of flows for all TCP and UDP applications. So these are not physical instances. These are virtual instances. These are virtual load balancers. If you want to achieve high availability with load balancer, you can choose availability sets and availability zones to ensure that your VMs are always available. So we talked about the SLA when it comes to availability set and availability zone. Set offers 99.95% and zone offers 99.99%. So based upon what level of application SLA that you're looking for, you have to combine your load balancing with availability zone or availability set. Alright, so availability set, just to do a quick recap on what is availability set. So availability set is a logical grouping that we use to isolate virtual machine resources from one another when they are deployed. So Azure ensures that the virtual machines that you put in an availability set run across multiple physical servers, compute racks, storage units, and network switches. So if there is a hardware failure or a software failure, only a subset of virtual machines is affected. So that's how. So the same IIS has been deployed in another rack. So if the rack 1 goes down, the rack 2 will still be able to serve the data. Another one that we discussed earlier was availability zones. So availability zone offers a group of 1 or more data centers that have independent cooling, power, and networking. So the virtual machines in an availability zone are placed in different physical locations within the same region. So we use this architecture to ensure that when an entire data center fails, you can continue use the servers. So availability zones don't support all the virtual machine sizes and aren't available in all Azure regions. So we have to check the documentation. So we talked about how to select Azure region, right? So check if you want to attain high availability using availability zones, make sure that your region has support for the VM that you're choosing and the support for availability zones as well. So going forward, so how to select the load balancer solution. So basically there are 2 types of load balancer. If you recall the scale set demonstration, we created a load balancer there. So basically there was a basic load balancer and there was a standard load balancer. So to talk about some of the differences between these two, these are different pricing tiers, and standard offers some higher features as well as SLA of 99.9%. So let's just take a quick comparison on what is basic and standard. Basic allows you to port forwarding, automatic reconfiguration, health probes, outbound connections through SNAT, diagnostics through Azure Log Analytics or public facing load balancers. And these can be the basic load balancers can be only used with availability sets. It cannot be used with availability zones. Standard load balancers, it supports all the features that basic support. Additionally, it supports HTTPS health props, availability zones, which was not there in basic, diagnostics through Azure Monitor, high availability ports, outbound rules, and a guaranteed SLA of 99.99%. So that's how you select which tier you want to go with, whether you want to go with the basic tier or a standard tier. So a public load balancer maps the public IP and port number of the incoming traffic to the private IP address and port number of the virtual machines in the backend pool. The responses are then returned to the client. So by applying load balancing rules, you distribute specific type of traffic across multiple virtual machines or services. So there are 2 distribution modes that we need to discuss when it comes to load balancing. So we already talked about 5-tuple hash, which is a default method. By default, Azure Load Balancer distributes traffic equally among virtual machine instances. The 5-tuple hash distribution mode is the default one. The tuple is composed of 5 elements. So we already saw what are the 5 elements. It's source IP, source port, destination IP, destination port, and the protocol type. So because the source port is included in the hash and the source port changes for each session, clients might be directed to different virtual machines for each session. So the source IP will keep on changing, right? So every time it doesn't have an affinity towards the source IP. That's the reason why this is ideal for if you want to complete load balancing. Most of the time it will go like a round robin thing, the 5-tuple hash. But the next method will help you understand why the relevance of this. So the next one is source IP affinity. So this distribution is known as session affinity or client IP affinity. To map traffic to available servers, the mode uses a 2-tuple hash. So it only considers the source IP and the destination IP. Or sometimes it can also use a 3-tuple hash, which includes the source IP destination IP, and the protocol type. The hash ensures that the requests from a specific client are always sent to the same virtual machines behind the load balancer. So there is a source IP affinity, right? So let's say my source IP is 10.1.1.1, and every time I come with that, it will be directed to the same server which I was accessing earlier. So it has an affinity towards the source IP. So next thing, whether we want to choose how to choose the distribution mode. So should I go for 5-tuple, 2-tuple, or a 3-tuple hash? So imagine a scenario where the requirement of the presentation tier is to use in-memory sessions to store the logged users' profiles and interact with the portal. In this scenario, the load balancer must provide source affinity to maintain user's session. The profile is stored only on the virtual machine that the client first connects to, because the IP address is directed to the same server. So when you create the load balancer endpoint, you must specify the distribution mode. So if you look at here, you can see that what is the session persistence. So should I go for client IP alone? That's a 2-tuple. Should I go for client IP as well as a protocol? That's a 3-tuple. So this is what we call session persistence. So the session will be persisted. So the next time the user comes back, let's say he already logged into VM1, and the next time the same person comes back, he will be directed to VM1. So because his session is already stored there, that's persistence. All right. So let's do a quick demonstration. So what we're going to do right now is we will create a load balancer. We will create 3 virtual machines. We will install IIS server on those with a particular landing page with the VM name. So every time we refresh, what happens is we will be getting a response from different VMs. We are not going for session persistence. Otherwise, I would get the same response ever, but we are going for the 5-tuple hash, which is the default method. So let's jump back to Azure portal and see how it works. All right, so before we go to the Azure portal and deploy, let's take a closer look at the architecture of what we are going to do. All right, so we will create a load balancer, which is a load balancer. We will create it here. So it has 2 parts. So there is a front end and there is a back end as well. So the front end is here. This is where people are accessing it from the internet. So this is the internet, and people are accessing the front end. And there is a back end as well. So if I divide this part is the front end, this part is the back end. So this is how the load balancer will look like. And what I'll do is I'll have a set of VMs in the back end. So I'll create a VM. You can also have a VM scale set. I mean, we already saw that example, right? So we can have a scale set which can be scaled up and down based on the requirement, and the load balancer will automatically, distribute the load. But for time being, we are just using standalone VMs, not a scale set. So we have the VMs in the backend. So what we're going to do right now is we will actually create a load balancing rule. So the rule is something that will come like this. This is kind of abstract for the rule that we are creating. We will say that whatever request comes to port 80, that need to be load balanced again to port 80. So whichever request comes in, it will go to the backend pool with the port 80. I can map it to something else. I can map it to 80 to 122 if I want. So whatever 80 comes to the front end, it will be redirected to 122 here. It's 122, 122, 122. So I can do that. I can change the port of my IIS or Apache, and I can do that as well. But we are just doing a regular workaround, like regular thing, like 80 to 80. That's what we are going to do. All right. So this is the load balancing rule. This is the load balancing rule. So there is one more thing which is called a health probe. So what health probe means is like, so you have different VMs. What if the IIS process on this server is down? And load balancer will not know that. Whenever a request comes in, let's say if it is directing to this VM, the user will not be able to access the web server. This connection is broken, right? So we will use something called a health probe. So in health probe, we will mention that this is my backend. I want to check on port 80. So the load balancer will check on port 80 and make sure that the VM is listening on that, whichever port you prefer, but here in the example it's port 80. So when the load balancer detects that the port 80 was unavailable, it will mark this VM as unhealthy. So once it is marked as unhealthy, all the request forwarding to this one will be stopped, and requests will be only sent to these two VMs. So that's what health probe is about. So these are the main things that we're going to talk about. We will have a front end, we'll talk about backend pools, health probes, then we'll load balancing rules. So these are the main concepts related to load balancing. So let's go to Azure portal and we will create a load balancer. So I'll create a new demo load balancing, and the instance details is demo LB. I cannot use space, so I'll just put a hyphen. And I will use a standard one. If you want, you can use standard one. Otherwise, that's completely fine. If you're using as standard, you get an option to select the availability zone, because when we discussed about basic versus standard, we talked about this. The availability zones are not available as part of basic. Alright, so public, basic, I'll create a new public IP address. So demo LB pub IP. It's fine. Standard, I'll select the availability zone as 1 for time being. So review and create, that's all. So it's gonna take a couple of seconds to complete the deployment. Yeah, it's done. So let's go to the load balancer. So the load balancer got a public IP address, and now we're gonna proceed with the backend pools. So in the backend pools, we're gonna add a new pool. The virtual network, I'm gonna leave it as blank, because we will come back and add the virtual machines and the virtual network. As of now, we don't have anything, so I'll just give a name. Let's say demo LB backend. I'll just give a name and I'll just add it, because we need a backend pool to create a health probe as well as a load balancing rule. So that's the reason I'm just creating a dummy backend pool, but we will come back to this place later and we will add the virtual machines. Now let's go to health probes. We will add a health probe. So demo LB health probe. So 80 interval. So how many? So every 5 seconds. As of now, every 5 seconds it will ping that port 80 on the backend servers. And if you get 2 consecutive failures, the backend server will be marked as unhealthy. So I'll keep it as it is, or you can increase the interval if you want. So I'll just create the probe. Let's go to load balancing rule. So I'll add a load balancing rule here. So web rule, because we are doing a web traffic routing. You can give any name. That's just the naming convention that I follow. TCP 8080. I have the backend that I created. It's taking the health probe. So this is where we select what level of persistence that we need. If you set to none, that means it's a 5-tuple hash. If I select client IP, that's source affinity. if that's a 2 tuple, and this one is a 3 tuple, like client IP and protocol will be considered in this one. Alright, I'll keep the remaining things as it is, and I'll click on OK. So that will create a web role. Alright, so now we need the backend servers. So what we're going to do right now is we will go back to virtual machines. We will add a virtual machine. So I'll go with the same resource group. So this is my VM1. I'll select the availability zone here. Let's do it in the same availability zone. You can have VMs in different availability zones to increase the high availability, but for time being, I'll just keep everything in availability zone 1. Let me switch to 2019 data center. I'll have a higher size. That's fine. Username, I'll give a username, password. So since we are going to work with the web traffic, we'll just add the port for NSG. So I'll just select HTTP port here. And I'll just change my disk. I don't need a premium SSD here. I'll go to management and I'll turn off this one. So it will go to the same VNet. So you can have different subnets. So when it comes to real world applications, what people do is like they will have different subnets for this. So this is your complete VNet. You will have a subnet here. This will have your load balancer, and you will have a subnet here with all the VMs. So this will be load balanced, and this will have a public IP where users will be reaching out. So this is the normal architecture that people use, and they will have further subnets where they will have a data tier, like they will have databases here. They will further create a load balancer here. So that's the internal load balancer that they will create. So the difference between internal and external is like internal will not have a public IP address. It can only have an internal IP address. Public IP address, public load balancer will have a public IP exposed to the internet by which users can reach out. So this will be an internal load balancer that will be used only for internal communication. It will not be exposed to the public because I don't want my database to be exposed to the internet, right? So that's one thing. This kind of architectures you will see a lot in the architecture center. All right, just one more thing. Here we will make a small change. I'll just go to networking and I don't want a public IP. So the reason I don't need a public IP is because my public IP is not required in this case. I have a load balancer which has a public IP which is exposed to the internet, and I don't need public IP. The public IP is chargeable, right? So I don't need a public IP for each of my VMs. So I'll keep all these as private so that I don't have to pay for 3 or 5 or 10 virtual machine IPs. Instead, I'll just pay for this public IP which will be shared between the VMs, like load balance between the VMs. So I'll just make the public IP as none, review and create. So this is VM1. I'll create another VM now. So let's go back to home. Let me create my second virtual machine. So this is going to be VM2. I'll put it in the same availability zone. 2019 data center. I'll choose this one. That's fine. I'll whitelist port 80 as well. So that's good. I just have to confirm my password again. Alright, so I'll go to disk, I'll make it standard HDD. Networking, I'll turn off my public IP. I don't need a public IP here because I'm using a load balancer. So you can directly do that from here. So if you want, you can directly attach your load balancing, but we will go with the traditional way of doing it. Review and create. So I have both the deployments in. Alright, so we have our VMs up and running, but we haven't configured the IIS server in that. So there are multiple ways you could do that. You could actually attach a public IP address, RDP to that and configure it, and then remove the public IP address, because we don't need the public IP address as we are going with the load balance solution. So what I'm going to do right now is I'll just create a GemBox VM. So by GemBox, so we will have a VM here which has a public IP attached to it, and it will be deployed in the same subnet as other VMs, our VM1 and VM2. So what we're going to do is we will RDP to this one, and then from there we will RDP to these VMs. From this VM we will use it as a GemBox to RDP to other VMs. So the advantage is like these VMs are more secure, like nobody knows that these VMs exist. So this will be only the act as a friend end. So we will create a third VM. Once we have configured everything, we can delete this one because we no longer need it, as these VMs will be part of a load balance solution. Right, so I have raised a request for a GemBox VM. So if I just go back to my virtual machines, refresh it, I'll have a GemBox VM. If I open this one, I will have a public IP. So I'll just copy that one, go to RDP. And the password for this one. Right, so while this one is getting started, let's go to VM1 and find the private IP address of this VM. Okay, that's the private IP address of the VM. We will come back to the RDP. So this will act as a GemBox for the RDP connections that we want. This one is exposed to the internet, others are not. So your web server application is, we are kind of increasing the security as of now. Right, it's up and running. So I'm going to open RDP from this one. I'm going to put the private IP address of the VM1. I'm going to hit connect. So it will ask me for the username and password. Alright, so we are actually going to our VM1 right now. I'll just take this one off, otherwise it will be confusing. Yeah, so if you look at the IP at the top, it's 10.1.2.4. So we are using a GemBox. If you don't want to do this, you can directly attach a public IP address. So I just wanted to make it more interesting, because this is how you actually create a GemBox VM to access the VMs that doesn't have a public IP address. So this VM can be used as a management VM if you want. So you can use this to manage your IIS servers without exposing them to the internet. All your web traffic will be coming through the load balancing solution, and you can have a GemBox as a management VM. Alright, so let's make a couple of changes here. So what we're going to do right now is we will first install the IIS server role on this VM. Alright, so for that we will use PowerShell, and we will install the IIS role. Right, so I'll just right click here, PowerShell Administrator, install Windows feature. I just hit tab to get the autocomplete. Yep. Name, web server, include management tools. So that's going to install IIS role on this particular machine. So while it is installing, I'll just go to my C drive and let me check if my landing page has been populated or not. Okay, it's not yet populated, so I'll just refresh. Once it is up, we will go ahead and change the landing page, because we need to know from which VM we are getting the response. So we will make a minor change in the HTML code, and we will use that to understand from which VM we are getting the response. So as it is installing, it will take a second to get the file. You will get a file that says inetpub. Yep, there you go, inetpub. So we'll go to www.root. That's where the landing page is. So I'll just right click and open with Notepad. Alright, so this is how the landing page HTML code will look like. I'll just I'll change a couple of things here. I'll just I'll add a line here. Hello world from VM1, and add something to the body. I'll just change the title as well. Okay, so let's save this and close this one out and see how it looks like in the. Yeah, so you see at the top I have added a line which says hello world from VM1. So perfect, it looks good. So that's all we needed. I'll just close out this one. That's fine. Let's RDP to the second VM. So we are still inside our jump box VM. I'll just hit here, go to RDP, and I'll just minimize this one and get the IP for VM2. So VM2 is 10.1.2.5. So I'll take that. I will come back to the RDP. I'll paste that. So trainer, that's my username. Connect. I'll input my password. Yeah, that's fine. So we are in VM2 right now, so we're gonna redo the steps again here. Alright, so I have updated the IIS landing page for this VM as well. So if I open that one, I should be able to see the similar line from VM2 here at the top. Yep. So hello world from VM2. I just added that. All good. So let's close this one. Close this RDP as well. Alright, so what we're gonna do right now is we will go ahead and configure the load balancer. So I'll go to load balancers, go with my demo LB, and I need to update my backend pool here. So we already created this backend pool during the load balancer creation. So I'll just select the VNet, add virtual machines. I have both the virtual machines available here. Add them and I click on save. Yeah, oh my god, it's just done. So I'll just click on go to resource group, and this is my load balancer. So I'll just copy the public IP, we'll come here, Hit enter. So this is coming from VM2. So this is how you load balance between your VMs, and I think that makes sense. All right.
So, that was a clip taken from one of the modules of our step-by-step training program on Azure Solution Architect certification, including exams AZ303 and AZ304. I would like to invite you for a free masterclass on how to kickstart your journey as Azure Solution Architect, right from learning basics like implementing storage account, virtual networking, and getting certified by using our step-by-step 12 weeks roadmap to go from complete beginner to a certified Azure Solution Architect. If you are interested, register for a free class by going on to K21Academy.com/AZ30302. I highly recommend you to go through this free class to see what to expect in the exam, learn basics about Azure Solution Architect certification, and to get a demo on deploying Azure Container Instance. So please visit K21Academy.com/AZ30302. Please click on the subscribe button so you don't miss out on our future videos. I will see you in another episode of Azure video series from K21 Academy. Till then, take care.